The year is 1347. A shadow creeps across Europe. It doesn't march. It doesn't roar. It arrives in silence and leaves only death. Villages vanish in weeks. Families are gone before dawn. The air itself feels poisoned. They call it the Black Death, a plague so fierce it kills over half of Europe's population in just a few years. Historians say it reshaped the course of human civilization. But for centuries, one question has remained unanswered. Where did it truly come from? Some blamed the stars, others, foreign merchants. Whispers spoke of curses, demons, even divine punishment. But none could prove the truth. Now, after nearly 700 years, scientists have done the impossible. They have extracted the ancient DNA of the killer itself and followed its genetic trail back to the moment it first appeared. The answer they found changes everything we thought we knew about the Black Death. So, where did the deadliest pandemic in human history really begin? And how could it have spread so fast? It began in the mid-14th century, a time when Europe was already fragile. The 100 Years' War raged between England and France. Crops had failed for years, leaving entire regions hungry and weak. Trade routes stretched from the ports of the Mediterranean to the far reaches of Asia, carrying spices, silk, and something far deadlier. By the winter of 1347, strange reports reached the Italian city of Messina. Ships arrived in port with crews already dying, their bodies covered in dark swellings the size of eggs, skin blackened by internal bleeding. The stench of death clung to the wooden decks. Within days, the infection leapt from dock workers to families, from neighbors to whole districts. From Messina, the plague spread like wildfire to Genoa, Venice, Marseille, Barcelona. Within months, it consumed France, Spain, and England. By the time it burned through Europe, an estimated 75 to 200 million people were dead. Half of cities were left in ruins, fields abandoned, and in some places, not enough living remained to bury the dead. For centuries, chroniclers argued over its origin. Some swore it came from the east, carried by caravans along the Silk Road. Others claimed it was born in the swamps of Africa. But none could trace its journey with certainty. That is, until a new kind of science gave us a way to follow the killer's trail, right down to its birthplace. It started in a remote graveyard in the mountains of Kyrgyzstan. The year was 2011, and a team of archaeologists had been cataloging ancient tombstones for an entirely different project. The graves dated back to the 1330s, just before the Black Death exploded in Europe. The epitaphs, written in ancient Syriac, spoke of a pestilence that claimed entire families in a single year. At first, it was just another tragic footnote in history. But one thing caught the scientists' attention: the sudden spike in burials within a very narrow time frame. In 1338 and 1339, this small community had been devastated. That was unusual for such an isolated mountain settlement, far from major cities or trade hubs. Driven by curiosity, the team carefully opened some of the coffins, hoping to find clues about the cause of death. Inside, they found remarkably preserved skeletons, protected by the dry, cold climate of the Tian Shan region. Dental pulp, the soft tissue inside teeth, can trap traces of bacteria for centuries, hidden away like a time capsule. If any pathogen had killed these people, there was a chance its DNA still lingered there, waiting to be found. The archaeologists sent the samples to genetic laboratories in Europe, where cutting-edge sequencing technology would soon breathe life into a 7-century-old mystery. What they found in those teeth would lead straight to the birth of the Black Death itself. The samples from the Kyrgyz graves arrived at the Max Planck Institute for the Science of Human History in Germany. Here, scientists specialized in extracting genetic material from ancient remains, a process that requires working inside sealed, sterile rooms to avoid contamination. Each tooth was cleaned, drilled, and its inner pulp carefully removed. The fragments of DNA inside were tiny, shattered by centuries of decay. But advanced sequencing machines could read these broken pieces like a puzzle, reassembling the genome of whatever had once lived inside the victims' bodies. Days turned into weeks as researchers compared the recovered DNA against a vast library of known pathogens. And then, a match appeared on their screens. Yersinia pestis, the bacterium responsible for the Black Death. This was no ordinary strain. Its genetic code was almost pristine, untouched by centuries of mutation. It was like stepping into a time machine, staring directly at the killer in its original form. But confirming the identity of the bacterium was only the first step. To understand where it came from, scientists needed to compare it with thousands of other strains collected from plague outbreaks across history and geography. This would mean building a complete family tree of the pathogen, tracing every branch back to its root. That root, they suspected, lay somewhere in the mountains of Central Asia. If they could prove it, they would solve one of history's greatest epidemiological mysteries. The genetic analysis was exhaustive. Scientists constructed a phylogenetic tree, a map of the plague's evolution, using samples from outbreaks spanning centuries, from medieval Europe to modern Madagascar. At the very center of this vast network of genetic data sat the strain from the Kyrgyz graves. It wasn't just old, it was the common ancestor of every subsequent plague strain in recorded history. In other words, this was patient zero for the Black Death. The bacterium's genetic fingerprint revealed that sometime shortly before 1338, Yersinia pestis had emerged in its most lethal form in this remote mountain region. The surrounding wildlife, especially marmots, which are natural plague reservoirs, likely played a key role in its first jump to humans. From there, the infection may have traveled with fur traders, carried along the ancient Silk Road routes, moving westward toward bustling trade hubs. The DNA evidence was indisputable. There were no other known strains older or more central in the evolutionary timeline. The Kyrgyz strain was the origin point, the place where the deadliest pandemic in human history was born. Centuries of speculation, blame, and myth had finally met the cold precision of science. The Black Death did not come from a curse, nor from the wrath of the heavens. It came from a tiny bacterium in a quiet mountain valley, waiting for the perfect conditions to ignite a global catastrophe. It is the early 1330s. In the high valleys of the Tian Shan mountains, life moves slowly. Traders pass through with caravans of silk, spices, and furs. Marmots scurry through the grasslands, carrying fleas infected with Yersinia pestis. One day, perhaps during a hunt, or while skinning a pelt, the bacterium jumps from animal to human. The first victims suffer fever, chills, and swollen lymph nodes, buboes, darkening as the infection spreads through their blood. The disease burns through the small community, overwhelming it in months. Traders, unaware they carry death in their bodies, load their goods and ride west, following the Silk Road. Each stop becomes a spark, igniting new fires of infection. By 1346, the plague reaches the Crimean port of Kaffa, where it finds a crowded melting pot of merchants, sailors, and soldiers. From there, it boards ships bound for the Mediterranean. Rats hide in the holds, their fleas leaping to sailors during the voyage. In 1347, Messina's harbor receives its infamous ghost ships. The infection leaps ashore, moving faster than anyone can flee. Within a year, It consumes the major cities of Europe. Streets are lined with carts of corpses. The air smells of smoke and decay. Priests read last rites over entire neighborhoods. No medicine works. In less than a decade, the Black Death has rewritten the human story, starting from a single point in the Kyrgyz mountains. For centuries, the origin of the Black Death was a riddle wrapped in fear and myth. People blamed enemies, foreigners, even the stars themselves. Entire communities were persecuted because no one could see the invisible killer. Now, with the precision of modern science, the truth has emerged from the bones of a forgotten graveyard. The deadliest pandemic in human history began not with war or sorcery, but with a microscopic predator thriving in the wild. From the marmots of the Tian Shan mountains, it rode with traders along ancient routes, igniting a chain reaction that would claim tens of millions of lives. This discovery does more than satisfy historical curiosity. It warns us, pathogens can leap from animals to humans at any time, in any place, and the next outbreak may already be quietly building somewhere far from our sight. The Black Death is no longer a mystery, but its lesson is clear. Our history is shaped not just by empires and kings, but by the smallest forms of life. And their power to change the world has never faded. If you were intrigued by this journey through time, don't forget to like this video, subscribe, and explore our other episodes, because the past still holds secrets waiting to be uncovered.